Hello everyone, my name is Rakesh Darsi from 3rd CSEA. We are belongs to batch number 17. Now we see the review on Tinkering Lab mini project. The title of the project is AI controlled micro sprinkle adjust sprays based on wind and soil moisture by using the application of community service. The following people are my team members that you see it on the screen. The methods we used in this project is me and my teammates went to field visits to gardens and communities, and we conduct the interviews and surveys with the farmers and residents. Finally, we did the pilot testing in community because for real-time feedback. Now we see the key insights of this project is user want water saving at efficient solutions. That means users prefer products that save water but still work efficiently. So now, need for low cost and easy to maintain sprinkles. There is a demand for products like sprinkles that are affordable and simple to maintain. Now, AI automation valued, but manual override required. That means while users value AI based automation, they still want the option for manual control when needed. Now, simplicity and sustainability preferred. That means users like products that are easy to use and environmental friendly. Now we discuss about empathy map of this project. First of all, we need to know what is an empathy map. An empathy map is a simple tool that helps to understand the user's perspective. It is divided into four main parts: what the user says, thinks, feels, and does. Now, user says we waste a lot of water with the traditional sprinkles. This means they are concerned about water usage. Users believe that AI should make irrigation smarter but not too complex. They want technology to help, but it should stay easy to use. Now users feels that he or she more worry about high water bills and the effects of climate change. This shows their emotional concerns about the cost and environment. Now users actively look for affordable, sustainable, and automatic solutions for watering so they can save water and money. Now we see project title and team. The first question of this project is what is the decided project title and subtitle? The project title of this project is AI controlled and micro sprinkle. The subtitle of this project is Smart Irrigation for Sustainable Growth. The second question of this project is does the title reflect the problem and solution clearly? For my perspective, yes, the title AI Control Micro Sprinkle reflects the problem of inefficient irrigation and the solution of smart automated water saving sprinkles in a clear conscious way. Now we see if anyone question me what is the context of your project, then I will answer them as urban homes, window planters and small community beds face irregular watering and water scarcity, especially in summer heat. Now, volunteers forgot or overwater. Pots and vary in size, so one fixed spray radius wastes water and causes uneven growth. Communities want low cost, low maintenance automation that anyone can use. The main purpose of this project is smart water conservation. This we can say as the primary purpose of this project to save water by delivering the exact amount needed for plants using AI based control and IoT technology. The secondary purpose of this project is create an educational, open and privacy respecting platform for learning sensors, AI and sustainability. The main objectives I defined in this project is AI driven smart irrigations. That means use AI to analyze soil, weather and plant needs for intelligent watering. And the second thing is user friendly control and monitoring. Provide an app or manual override option for real time control and flexibility. And the third thing is sustainability and scalability. That means create an eco friendly solution that works for small gardens and large farms alike. There is a three problem statements have involved in this project as draft. The first one is what problem are you addressing? We are addressing the challenge of excessive water wastage and inefficient irrigation practices in gardening and farming. Many existing systems either overwater or underwater leading to reduced crop health and unnecessary resource loss. What is the background and relevance of this problem? For this, I will explain an example. Imagine a farmer who uses old sprinkles in his field. Sometimes the sprinkles use too much water and flood the crops. Other times they do not provide enough, making the plants dry. This wastes water and can ruin the harvest also. The farmer wants a smarter solution that saves water. is easy to use, not expensive, and can be controlled by him when needed. The solution of this problem is a new system with AI technology could solve this problem. It can automatically give just the right amount of water to the crops and even let the farmer control it manually if needed. This helps the farmer saves water, money, and grow healthy crops while protecting the environment. Here, see, our project is highly relevant because it combines AI technology with eco-friendly sprinkling systems, making smart farming accessible to both communities and individuals while supporting the global movement towards sustainable agriculture. That what you we see in this the example. Now the third statement is, how did you validate that this problem exists? We validated the problem through field visits, farmer interactions, and community surveys, and which revealed that users want water saving, low cost, and easy to maintain system. Pilot testing has confirmed that people appreciate AI driven automation, but also value having a manual override option for flexibility. Now, see problem statements of refine. The first problem statement is, how did you refine the problem statement? We refined the problem statement by moving from a general issue of water wastage in irrigation to a specific AI driven solution that focuses on precise water distribution, real time soil moisture analysis, and sustainability. This made the problem more focused and practical and solvable. The second problem statement in this is, what are the critical aspects highlighted in the refined version? Water conservation through micro level sprinkling, AI based decision making for when and how much to irrigate, and crop health improvement by avoiding over and underwatering, sustainability by reducing resource waste, accessibility. So even small farmers or home gardens can benefit. Now see, let me clarify with an example. Imagine a small farmer who often uses too much of water on his crops because he is not sure how much they really need. With an AI driven sprinkle system, the sprinkles checks the soil and only gives the plants the right amount of water at the right time. This saves water, helps crops grow better, and is easy for the farmers to use even for someone with a small farm or a garden. Now, the third problem statement is the problem statement measurable or actionable? Yes, measurable. In measurable is water saved in liters. Crop yield improvements and energy efficiency can all be tracked. And actionable also. The AI system can be implemented, tested, and scaled in real farming or gardening environments. Now we see brainstorming of this project. The first question is, what brainstorming techniques were used? I used group discussions and mind mapping. How might we technique questioning techniques. This helped us explore challenges in irrigation and reframe them into opportunities for AI driven solutions. Let me give an example. How might we technique? If anyone asks me, how might we save water while still giving enough water to crops? Then ideas are generated by use sensors to detect soil moisture, or use AI to predict the best watering time, or our project micro sprinkling, and a connect system with weather forecast. This is how might we technique works. The second question is, how many ideas were generated during brainstorming? I generate around 12 to 15 unique ideas, ranging from simple smart sprinkles to advanced AI based microcontrol systems. After evaluation, we refined and selected the AI control microsprinkle as the most impactful. For an example, AI alerts and notifications, soil moisture sensors, AI prediction models, etc., and mobile app control. Mobile app control means farmers can monitor and control from phone. AI prediction model predict crop water needs using past data, and solar powered system reduce electricity usage and eco-friendly, and the tracking of water, that means shows how much water is saved daily and weekly or monthly. Yes, the third statement is, were sketches and mind maps are created? Yes, I created sketches, flow diagrams, and mind maps. I created a mind maps to visualize the concept. These helps us clearly understand the system architecture, data flow, practical implementation of this project. The mind map of this project, we can see it right bottom of this slide. See, AI control micro sprinkle. Now IoT connectivity, mobile app, water usage tracking, and mobile phone, and AI forecasting, and smart watering, and There is a soil moisture sensor and machine learning. This is an example diagram for this project. Not exactly. This is just an example. The final step of this project is idea generation. In idea generation, the first question is how did you select ideas from brainstorming outcomes? I selected ideas by first grouping similar ones together, then evaluating them based on how well they aligned with the main goal of the project. Creating an AI controlled, efficient, and sustainable micro sprinkle system. After clustering, we prioritized unique, innovative, and practically implementable ideas. The second question is what criteria were used to filter the best ideas? I used the five criteria to filter the best ideas. Those are feasibility, impact, innovation, scalability, simplicity. Those five criteria has involved in this project. The criteria you see it on the screen. The third question is did you consider feasibility and impact while ideating? I can say that yes. In feasibility, for an example, we eliminated ideas that required expensive, high-end AI chips or sensors are not easily available at market also or anywhere. And in impact, we prioritized ideas like soil moisture sensing and AI irrigation scheduling and weather prediction based watering, since these directly save water and increase yield. Finally, I concluded that the AI controlled micro sprinkler is a smart, sustainable, and scalable solution that saves water and boosts crop productivity, and it automatically adjusts water flow and timing, helping farmers save water, improve crop yield also, and reduce manual effort. The system is feasible, scalable, and sustainable, making it a practical solution for modern agriculture. Thank you, everyone.